Let's look at this number named the Euler. It looks like Euler, but it's pronounced Euler. All right. Now, this is one of the numbers that you often see in mathematics, and in the case of differentiation, you see that dy, well, if you have y is equal to e to the x, dy by dx is equal to e to the x. And this is also the base of natural log, alright? Log with a base of e of a number. It's written as ln. So ln x is a logarithm with a base e. Now, suppose you have, for example, you have some money in an account and you look at the time it will take to double your money given the interest. Well, you probably recall that compound interest, when you calculate compound interest, the principal time 1 plus r divided by 100 to the power of n, where r is the rate in percent and n is the number of years. R is the rate in percent per annum or percent per year. This is in percent. Now, it will be the same as 0.01 r, alright? But since we are fixing the time that it will take to double your money, let's just call it r as that rate. Now, suppose the rate that you're getting is 100% per year. So in that case, 100 over 100 is 1. So after the end of that year, you get p times 1, which is your principal, plus p times 1, which is your principal again. So you're doubling the principal investment, all right? You're actually doubling the amount of money. All right. So in that case, the rate is given over the same time as it takes to double your money. And in this case, n is 1. 1 whole year. Imagine that is 1 year. Now, suppose you're taking the money out but reinvesting it after 6 months. So what happened in 1 year before is now happening in 2 years. Now after 6 months, what do you have? Is a principal times 1 plus. In this case, it is half the rate that you're getting. All right? So if it was, say, 10% per annum after 6 months, you're getting 5%, which is half a year. So whatever the rate is, what you're getting is the rate over 2. Alright? But in this case, it is 100%. So let's just use 1 for the number. It is 1 over 2. Now it will mature at 6 months and then mature at the end of the year. So at the end of the year, you will have done this 2 times. So the n, the number of time that matures, would be 2. Alright? Now suppose instead of every 6 months it matures every 4 months. So in this case, 4 months, which is 3 times per year. Now, the compound interest that you'll get at the end of the year will be the principal 1 plus, because remember the principal must be multiplied by 1, you get back the same money you invested, and then the interest will be out here. So this 1 plus, the rate is 1 out of 1, it's 100%. But 3 times per year, every 4 months is 3 times per year. So if you have the loan, or call it a loan, the bank is borrowing money from you then, because you have put the money in that account. The loan matures at 6 months, no, at 3 months, then 3 months, then another 3 months. That's 3 times. So what you get is the rate divided by 3 at the end of that 4 months, which is 1/3 of a year. You get 1/3 of the entire interest for the year. Now, this happens 3 times for the year, so you must raise this to the 3. And remember, if you're confused about how you came up with the raised to the power and the original formula that says P is 1 plus R over 100 to the power of n, or you get the n, you'd have to review your compound interest formula and how it is formulated, but we won't go into it in this video. Now, suppose you say, no, you want the money to mature and be reinvested every 3 months. Every 3 months would be, in this case, 4 times per year. So it's the principal, and 1 plus 1 over 4. 4 months is 1/4 of a year. So you get 1/4 of the rate of the interest to the power of 4. Because it will happen, for example, January, February, March, April, May, June, July, August, September, October, November, December, January again. So every year it happens 3 times. So let's say it matures in January. So you put in the money in January, February, March. Then it matures April, May, June, July. Matures again in July, August, September, October. Matures again in October, November, December, January. So every January, April, July, and August, which is 4 times a year, the loan matures and reinvested. Alright. Now, so far, what we have here is 1 plus 2, 1 plus half squared. So let's see something here. Let's do a calculation. 1 plus half squared. We have a raised to the power here. Alright, let me put it back in advanced mode. So it's 1 plus, open bracket, 1 over 2, close bracket, equal. And that raised to the power of 2 equal. It's 2.25. So for the whole year, you get 2.25 of the principal. The principal is multiplied by 2.25. In this case, the principal was multiplied by 2. Now it is multiplied by 2.25. What happened with the 1 plus 1/3 cube? Let's see. Suppose we have, open bracket, 1 plus 1 over 3 to the power of 3. Yeah, 2.37. Alright? So principal will multiply by 2.37. In this case, 1 plus a quarter to the power of 4. Alright, let's do it this way. It's 1 plus 1 over 4 equals to the power of, that to the power of 4 give you 2.441. 2.441. 2.441. Alright. Now suppose you say, I want the loan to mature every month. So every month the loan matures and reinvested. The principal time 1 plus whatever you would get as a rate every year. Every month you get 1/12 of that. So the rate divided by 12, because 12 months make a year. And this reinvestment would happen 12 times every year, so it's to the power of 12. So let's see what this becomes. 1 plus 1/12 to the power of 12. Alright, 1 plus 1 over 12 equal, okay, to the power of 12 equal 2.61. So you get 2.61. Alright. Now, suppose you say, instead of every month, I want you to calculate calculate how much you would get at the end of the year if this loan matures every day, and then that amount of money is reinvested every day. The compound interest that you get per year would be the principal times 1 plus 1 divided by whatever interest rate you got for the year. You're now getting 3/65 of that, because 365 days are in a year. So it's 365. And since the loan matures and is reinvested every day, it will happen 365 days over the year. So it's raised to the power of 365. So let's see what happens in this case. What you have is 1 plus 1 over 365 equal, okay, and that is raised to the power of 365 equal 2.7145, call it 2.715. So you have 2.715. Now suppose you say, no, I want the loan to mature every hour. Now, what you will get happening if the loan matures every 1 hour and is reinvested after every hour is the principal 1 plus 1 over how many hours are in a year. You have 24 hours in a day times 365 days in a year. You get 8,760. So it's 1 over 8,760 raised to the power of 8,760. Because 8,760 hours are in a year, what you would get for the loan is 8,760th. The rate would be 8,760th of that for the whole year, and since it matures and is reinvested every hour for the year, that would happen 8,760 times. So let's see what number this will yield 8760. So it's 1 plus 1 divided by 8760 equals, okay, and that is raised to the power of 8760 equal, right? Now let's do it again this way. Open bracket, 1 plus 1 over 8760 close bracket to the power of 8760 equal, okay, good, 2.7181 something another. So it's 2.7181 something. Now the thing is, you consider the limit of this thing as you shorten the number, the amount of time from months to days to hours and so on, and increase the number of times that this happens. What you're looking at is the limit as, say, n approaches infinity of p 1 plus 1 over n to the power of n. Now, p will be multiplied by this, and the Euler is actually this number as n tends to infinity, because if you consider n, for example, being 1,000,000, if n is 1,000,000, what you'd have is 1 plus 1 over 1, 1, 2, 3, 4, 5, 6. Let me put this in bracket, close bracket, to the power of 1, 1, 2, 3, 4, 5, 6 equal 2.7182846. If you do that again, let's suppose we make it 5 million then, to the power of 5 million, 2.718281557, and so on and so forth. So that number to 3 decimal places is 2.718. Now you could, let me see, does this calculator have it? Alright, this is E. You will see on your calculator 2.718281828, and it goes on and on and on, right? And if you look online, you will see this number, the Euler, with many more decimals after the 2. So this is actually how you get this number. We call it Euler, and it's represented using lowercase e. It's named after Leonhard Euler, E-U-L-E-R. All right. Okay, so that will be it for now. This was just to show you the origin of this number. Very important number, and a number that you will see sometime in mathematics. I'll see you in the next video. See you.